You look up at the night sky, and it seems so peaceful.
Yeah, mostly. But hidden out there are the most powerful particles we know about.
Ultra-high-energy cosmic rays. UHCRs. And the thing is, for 60 years, we've had this, nagging question.
Where do they come from? It's a huge mystery. These things have energies like 1,000,000 times higher than our biggest accelerators.
1,000,000 times. It's hard to even grasp.
It really is. Pinpointing the source has been, well, a major challenge in astrophysics.
But now, maybe there's an answer. There's this new theory from Glennys Farrar at NYU.
That's right. And it could be a really significant step. It connects these UHCRs to some of the most violent events in the cosmos.
Okay, so that's our mission for this deep dive then, to unpack Farrar's idea.
Yeah, figure out what it means for understanding these extreme events and even, surprisingly, how heavy elements get made.
Heavy elements like gold.
Exactly. Gold, platinum, uranium, things like that.
Wow. Okay, so what's the core idea? Where does Farrar say these particles are born?
She proposes they're accelerated in the messy, turbulent magnetic outflows from binary neutron star mergers.
Binary neutron star mergers. Okay, break that down. Two neutron stars colliding.
Precisely. Imagine these incredibly dense objects, neutron stars, spiraling closer and closer together.
They're losing energy as they do that, right? Through gravitational waves.
Exactly. And based on simulations like that NASA one, the actual merger is unbelievably fast. We're talking under 8 milliseconds.
8 milliseconds. That's instantaneous, practically.
Pretty much, and it's incredibly violent. When they collide, their magnetic fields get hugely amplified, all tangled up and chaotic.
Like twisting magnets together, but on a cosmic scale.
A good way to think about it, yeah. Super strong fields getting scrambled. And eventually this mess collapses into a black hole.
And jets shoot out.
Powerful jets, yeah, launched by the reconfigured magnetic field. And it's in these outflows, Farrar suggests, that the UHECRs get accelerated.
And this links back to the heavy elements you mentioned. Gold, platinum.
Yes, exactly. These mergers are thought to be the primary factories for many heavy elements through something called the R process.
The R process, rapid neutron capture.
That's the one. So Farrar's theory connects the dots. The merger creates heavy elements and accelerates some of them to become UHCRs.
So it's not just explaining the particles, but also giving us a new angle on how these elements are formed.
Right. Farrar herself pointed out it's like a new tool to probe these cataclysmic events.
Okay, so this sounds plausible, but there have always been these big puzzles with UHCRs, haven't there?
Two main ones, yeah.
One was the connection between how much energy a UHCR has and its electric charge. They seem tightly linked.
Right, and Farrar's model seems to explain this. The acceleration mechanism within those turbulent outflows, the theory goes, naturally links a particle's final energy to its charge.
Okay, so the physics of the merger outflow accounts for that correlation.
Yeah.
What about the other puzzle?
Just the sheer energy. The highest energy UHCRs are just ridiculously powerful. What engine could possibly do that?
Yeah, where does that kind of power come from?
Well, think about the forces involved in merging two neutron stars. Immense gravity, incredibly strong, rapidly changing magnetic fields. That's the kind of environment, the kind of sheer power needed to accelerate particles, specifically heavier nuclei, to those extreme energies. The merger itself is the engine.
So the theory seems to address these long-standing questions. But crucially, can we test it? How do we verify this?
That's the key, isn't it? And yes, Farrar's theory makes specific, testable predictions. Two main ones stand out.
Okay, what's the first one?
First, it predicts that the highest energy UHCRs should actually be some of these heavy, rare R process elements. She specifically mentions nuclei like xenon or tellurium.
So wait, we could actually look at the cosmic rays hitting Earth and see if they're made of xenon.
Potentially, yes. Future experiments or analysis of existing data could search for the signatures of these specific heavy elements within the UHCRs. It's like looking for the fingerprint of the neutron star merger.
That's amazing. Finding xenon nuclei traveling across intergalactic space. What's the second prediction?
The second one connects different kinds of cosmic messengers. It predicts that if we detect extremely high-energy neutrinos...
Neutrinos, right? The ghost particles?
Exactly. If we detect ones that likely came from UHECR collisions with background light, they should arrive potentially near simultaneously with gravitational waves.
From the original neutron star merger that created the UHECR in the first place.
Precisely. So you'd get a gravitational wave signal from LIGO Virgo Cagra and potentially a high-energy neutrino signal pointing back to the same event. multi-messenger astronomy.
Seeing and hearing the same cosmic event, that's a powerful confirmation.
It would be very strong evidence, yeah.
So this research, it seems to tie a lot of threads together.
It really does. It offers this, compelling and importantly testable narrative for a 60-year-old cosmic puzzle.
Right, so wrapping up, Glennys Farrar's theory proposes that ultra-high-energy cosmic rays, the universe's most energetic particles, are forged and accelerated in the violent death spiral of binary neutron star mergers.
And in doing so, it connects these particles to the creation of heavy elements and makes predictions linking them to gravitational wave events. It paints a much more unified picture.
It's quite something. These incredibly destructive events, these neutron star collisions, they're not just destroying things, they're actively creating the heavy stuff, maybe even the gold in our jewelry, the iodine we need to live.
And flinging some of it across the universe at unbelievable speeds.
Makes you wonder, doesn't it? If these extreme events forge the very elements that make up our world and send out these incredible particles, what other fundamental secrets are locked away in these violent corners of the cosmos, just waiting for us to figure them out?